Okay, this is video 2 from 1.11. We're looking at polynomials and writing things about them from different forms, standard form, factored form. So we're on example 2. Example 2 is a rational function and it's in factored form, and so we'll be able to do quite a few things from this factored form. So let's see. The first thing we need is the domain. Now, domain is going to be everywhere except where it will have a vertical asymptote. And so we can write it in two forms. I prefer to write these in set notation where it's not equal versus interval notation. But for this one, I'll do both. So for the domain, if we're going to write in set notation, we would say x such that x, and it's not going to be equal to, it can't be equal to -3, and x cannot be equal to 1. And so that's how you write it, the domain in set notation. Now in interval notation, it's more complicated because you have to come from -infinity to -3, and then it goes from -3 to 1. And then it goes from 1 to infinity. So you can see probably why I like set notation for these rational function domains. Now, the zeros come from looking at the top, because if you set this function equal to 0, of course you would multiply the denominator by 0, so it gives you 0. So really you're left with 3x and x minus 5 equals 0. And so you always just look at the top to find your zeros. So we have x equals 0 and x equals 5. So sorry. Let's put that down here. X equals, now it's asking for the zeros, not the intercepts, which would be points. So zeros are numbers and they're values for x, and if there's more than one, we should put it in set notation. So 0 and 5, those are the two zeros that we have. All right, now if you look at the function, it's asking about a hole. Now a hole would occur if we had the same pair, binomial pair, on the top and on the bottom, but we do not, so there's no hole, so just write none. Now, vertical asymptotes are where our domain didn't exist, and so we can say we have, now, an asymptote is an equation of a line. Excuse me. And so make sure that you write it, don't just give me a number here. You need to write it as a line. So it would be x equals -3 and x equals 1. There are two vertical asymptotes. Now, horizontal asymptotes, we might want to go back and put this in, general form to try to find our degrees and things. So if I'm going to look at this, I'm going to multiply the top out, 3x squared minus 15x. And on the bottom, I would have x squared minus x plus 3x. So that would be plus 2x. Minus 3. Now, remember the rule about your horizontal asymptotes. You look at the leading coefficient of each one, and if the degree is the same, then it's the leading coefficients over the leading coefficient. So that would be 3 over 1. And so, because they're both x squared, and so we would have y equals 3 as our horizontal asymptote. Again, a horizontal asymptote is an equation of a line. Okay, so we would write it as y equals 3. Now the y-intercept would just be if you put in f of 0, you put in 0 for x, and you would get 0 over -3, which is equal to 0. Now, that's just a number, so if we need the point, it would be 0, 0. Okay, let's look at example 3, and we're also going to sketch it, but it doesn't say that, so I'm going to add G down here, sketch. Okay, we have another rational function. It is in general form, not in factored form, so the first thing we're going to do is we're going to factor it. So this looks like the top is going to be factored into x minus 4 and x plus 3. I hope you're all up to date on your factoring. If not, you need to practice. The bottom would be x and then x squared plus x minus 20. And that would go further. You have x minus 4 still on the top and x plus 3. And then on the bottom, you have x, and then this would factor to 5 and 4 with a positive 5, because that's a positive 1x. So x plus 5, x minus 4. So there's our factored form. So let's write that down here. Now let's write the whole thing. K of x is equal to x minus 4 times x plus 3 over x plus 5 over x minus 4. Now, I see, obviously, that I can cross out my 4's, but for now, we're not writing simplified form. We're just writing in factored form, so I'm not going to cross those out. But I'll be thinking about that when they ask me the next things. Okay, so let's go to the zeros. So I'm going to say in my mind or somewhere, I'm going to write what this is with those gone. And remember, it asked me for a whole here, so I'm going to go right back and put the whole. That I have a whole. It says find any x values where k of x has a whole. So we would say that x equals 4 is where there's the x value. Now, it could ask for the point, and you would have to put it back into the original equation, but it just asks for the x value. Okay, so you're good to go there. So I said I was going to rewrite this with the whole crossed out. So I'm going to write it down here. K of x is equal to x plus 3, this is the simplified version, over x times x plus 5. So when I answer some of the other questions, that's what I'm looking at. Find any zeros of the function. So I would have, there's not a 0 at 4, because that got crossed out. So the only 0 from the top right here would be x equals -3. All right, so we've done A, B, C. Now we're on D. Find the vertical asymptotes of k of x. So if I'm looking at, it's easy to look right here, down here. I guess I'm pointing down there, right here. And that's going to be where my vertical asymptotes are. So I'm going to have a vertical asymptote at x equals 0 and x equals -5. Find any horizontal asymptotes. Okay, actually, this is going to be nicer to see from the, I'm way up here now, you guys. I'm up here looking at the general form, which helps me more with the horizontal. And I have a degree on the bottom, 1 larger than the degree on the top. The numerator has 1 less degree less than the denominator. And so if you remember our little rule, if the degree on the bottom is 1 larger than the degree on the top, then you have a horizontal asymptote at y equals 1. I mean, y equals 0. Y equals 0. Okay, so remember that rule. If you don't, you need to go back and look it up. Now, find the domain of k of x. Now, before I find the domain, I am going to sketch it because it's so much easier to report the domain after you've sketched the graph. So we're going to use what we have to sketch this graph. So the first thing I know is that I have a vertical asymptote, and I'm going to use green to do this, at x equals 0 and 1 at x equals -5. So I'm going to put this here. Okay, I also have a 0 at -3. So I have a 0 right here. I also have a horizontal asymptote at y equals 0. So guys, in my class, we always draw out our asymptotes. They're part of the graph. Okay, so now, let's see. I know that I am going to have pieces. I'm going to have a piece here or a piece here, and then I'm going to have a piece here or a piece here, right? And so I am going to look at a couple of points just to figure out, and I also know I have a hole. Don't forget this hole right here. So I'm going to just look at my graph, and it would be nice if I knew what the value was here at 1. I'm right here looking. I shouldn't have put a dot there, but I'm over there looking at that. And so what is y if x is 1? So I'm going to make myself a little table just so you can see what I'm doing. And so if x is 1, y, okay, so you're going to go over here, is 4 over 6 or 2/3. Now, 2/3 is positive, so at 1, I'm at 2/3, about right there. Oops, let me zoom in, about right here. So that means that this graph has to go, because of the asymptotes, like this. So it has to curve around and grab those asymptotes. Now, what I haven't done is put my hole in. So at 4, I'm going to take my eraser, 1, 2, 3, 4, and I'm going to erase, and then I'm going to put my hole in right there. All right? Now, go to the middle part. It could either go like this, or like this, or like this. There's many ways it can go. Okay? And so I'm going to test, let's test a point inside here. How about -4? Let me go with a -4. So if I put in a -4, I get -1 over -4 times 1. So I got -1 over -4, which is 1/4, positive 1/4. So that means at -4, I'm positive 1/4. So I have to be coming down from here, and I have to hit this 0. And now I don't know whether I go back up or I go back, or I come down this way. So I am going to test maybe -1. So if I test -1, I get 2 over negative times -4. So I get a -1/2. So at -1, it was at -1/2. So there's my middle piece for this graph. Okay, now remember, a rational function can cross a horizontal asymptote. It can't cross a vertical, but it can cross a horizontal. So now I'm left with deciding whether I'm here or here for this third piece. Okay, so I am going to test 6, -6. So if I test -6, I get -3 over 6, which is -1/2. So I know I'm down here, so I know my graph has to go like that. All right, so that's the graph. So now we have to be able to write the domain. Now, the domain cannot equal -5, it cannot equal 0, and it cannot equal 4. So let's just write that out. X such that x is not equal to -5, x is not equal to 0, and x is not equal to 4. That's it in set notation. All right, I'm going to stop that video here.